This is the Homeschool Chemist, and today we're going to explore the benefits of dimensional analysis in solving chemical calculations. So we're going to solve this problem two ways today, and we're going to see the first way, which is the hard way, and then we're going to solve it using dimensional analysis. So our question asks, a commercial antacid tablet contains 500 milligrams of magnesium hydroxide. How many milliliters of stomach acid will this neutralize? Consider the stomach acid to be 0.1 molar. So the first step in this problem is going to be to write a balanced chemical equation. So we have our reactants, magnesium hydroxide, MgOH2, plus HCl is going to form H2O plus magnesium chloride. Now, in order to balance this chemical equation, it's real simple. We can see that it's going to, for every one magnesium hydroxide, we're going to neutralize two acids, and that's going to give us two waters and one magnesium chloride. And we can see that we have the same number of each element in atoms on each side of the reaction arrow. So now we need to go from milligrams of magnesium hydroxide to milliliters of acid given a molarity. And this is going to be a multi-step process. So the first thing we have to do is go from milligrams to grams of magnesium hydroxide. So 500 milligrams of magnesium hydroxide. Well, we need to divide by 1,000 because the conversion from milligrams to grams is going to be to divide by 1,000. And that's going to give us 0.5 grams. The next thing we need to do is we need to add up the molar mass of magnesium hydroxide and then divide our mass of magnesium hydroxide by the molar mass in order to find out how many moles. So if we were to add up MgO2H2, we would find that it weighs 58.33 grams. So 58.33 grams. So this is going to allow us to go from grams of magnesium hydroxide to moles, because that's what we're solving for here. If you have a mass of a substance and you want to find out how many moles you have, you just divide by the molar mass. So 0.5 divided by 58.33 is going to be 8.6 times 10 to the negative third. Now this is going to be moles of magnesium hydroxide. The next step is going to be to go from moles of magnesium hydroxide to moles of hydrochloric acid. We see from our balanced chemical equation that it's a 2-to-1 ratio. So we're going to want to multiply this number by 2. So if we take 8.6 times 10 to the negative third and multiply it by 2, we are going to be left with 1.71 times 10 to the negative second. And this is going to be moles of HCl. Now, knowing what we know about molarity, we know that molarity is equal to the number of moles over the volume in liters. So we're given the molarity of HCl here, which is going to be the number of moles in a liter of substance. So if we want to go from molarity to volume, we just need to rearrange this equation here to be volume is equal to the number of moles over molarity. So we need to divide by molarity. So we're going to divide this 1.71 times 10 to the negative 2 by 0.1, and that is going to equal 0.171 liters. And now the question wants us to find this in milliliters. So 1.71 liters. To go from liters to milliliters, we have to multiply by 1,000. And that's going to be equal to 171 milliliters. Now, this is the correct answer, and this is a way to solve this. But as you can see, the work is much more confusing and it's easier to get lost in here and keep track of what your units are. So what if we solved it using dimensional analysis? What would that look like? If we were going to solve this using dimensional analysis, we would have 500 milligrams of magnesium hydroxide, 1,000 milligrams is equivalent to 1 gram, and then 58.33 grams is equal to 1 mole of magnesium hydroxide. 1 magnesium hydroxide is equivalent to 2 hydrochloric acids, and we got that from our balanced chemical equation. Now we're going to use our molarity here. 0.1 molar or 0.1 moles of HCl is equal to 1 liter of HCl. And then 1 liter of HCl is equal to 1,000 milliliters of HCl. So now this is solving using dimensional analysis. Now if we go ahead and look at our units, we're going to see that milligrams is going to cancel and we're left with grams of magnesium hydroxide. Now grams is going to cancel and we're left with moles of magnesium hydroxide. Well, now we have moles in top here, moles in bottom here. Those are going to cancel. We're left with moles of HCl. Now moles of HCl are going to cancel and we're going to be left with liters of HCl. Now liters is going to cancel, and finally we're left with milliliters. And if we multiplied all this through, we would find that it is equal to 171 milliliters of HCl. Or in other words, the tablet that weighs 500 milligrams of magnesium hydroxide would be able to neutralize 171 milliliters of 0.1 molar hydrochloric acid. As you can see here, solving with dimensional analysis allowed our problem to be much more organized, and we can see how our units cancel, and it's a lot harder to mess up when you're doing a problem this way versus the long way, even though they both work. So that is how we solve using dimensional analysis.